Hello friends, today we can discuss with single phase induction motors. Program is Diploma Engineering, third year Electricals. The course is Industrial AC Machines. Unit is single phase induction motors. The lecture number 1 for the introductions of single phase induction motor. Now myself, Mr. N.B. Ranodkar, we have completed the 7 years teaching experience in lecturer. Now, single phase induction motors. The single phase induction motor is the most frequently used motor for applications on the basis of residential as well as commercial and industrial. It is used for refrigerator, washing machine, clocks, drill machine, compressors, pumps, and so others. The single phase motor stator has a laminated iron core with two winding arrangement, perpendicular, one in the main and other is auxiliary winding or starting winding. For reasons of economy, most house, office and also rural areas are supplied with single phase AC as the power requirement of individual load items and their smalls. The operating principles of single phase induction motors. The single phase induction motors operations can be described by two methods. First one is double revolving field theory and another one is cross field theory. Now, double field revolving theory is prefers for easier of the two explanations to understand, so we will discuss as the double revolving theories only. Now, what is double revolving theory? A single phase AC current supplies the main winding, that is producing a pulsating magnetic field. In order to make the induction motor self-starting, it is necessary to produce a rotating magnetic field. And in order to do, there should be least two magnetic field which is satisfied the following two conditions. First one, the two magnetic fluxes should be shifted by 90 degree with respect to each other if one flux is horizontal and another flux is vertical. Also, two magnetic fluxes should be time quadrant. If the flux are represented phasor, then there should be 90 degree phase shifted between them. That means there are two fluxes, one is horizontal, another one is vertical. These two fluxes are 90 degree with each other. Mathematically, the pulsating field could be divided into two fields which is rotating in opposite directions. The double revolving field theory states that any alternating quantity can be resolved into two components which rotate in opposite direction to each other, with one having a magnitude which is half of the peak magnitudes of the alternating quantity. Okay, now let us apply this theory to single phase induction motors. Assume that the stator winding produces the alternating flux with the peak value of phi m. That means one main flux is called as the maximum flux of produced by the stator winding. Then, as per the revolving field theory, we can resolve these two fluxes into two components. That means this phi m is divided into 2. That means phi m divided by 2. And these two fluxes, that means phi m by 2 and phi m by 2. These two fluxes are rotate in opposite directions. Okay. Now, the interaction between the field and the current induced in the rotor bars generated oppositions of torque. The resultant of these two components will be resultant of stator fluxes at the given instant of time, and the continuously rotations of two components will result in original stator fluxes. Now this is a double revolving theory. Now starting torque. At the initially the motor is stationary. For rotations of motor, there are some torque will generated. Now what is the meaning of torque? Torque is nothing but it is a force into displacement. The single phase motor starting torque is 0 of the pulsating single phase magnetic fluxes. The starting of the motors required to generate a rotating magnetic fluxes, similar to the rotating flux in the three-phase induction motor. Two perpendicular coils that have current 90 degree of phase can be generated the necessary rotating magnetic field which starts the motor. Therefore, single phase motors are built into two perpendicular windings. In single phase induction motors, there are two main windings are used. One is main winding, another one is auxiliary winding. Auxiliary winding is also called as starting winding. These two windings are placed with 90 degree to each other. That means one is placed at 0 degree, the another one is placed at 90 degree. These are the two windings. That means these two windings are the phase difference is 90 degree to each other. The phase shifted by achieved by connecting a resistance, inductance and capacitance in series with the starting winding. The most frequently used is a capacitor to generate the starting torque. Now, next one. In case of single phase induction motor, there are four main types. One is split phase induction motors, another one is capacitor start, capacitor run, next one is capacitor start, induction run, and fourth one is shaded pole induction motors. These are the four types of induction motors. Now we can discuss with the first split phase induction motor. In split phase induction motors, the two windings are used. One winding is main winding, another one is auxiliary winding. The main winding have the low resistance and high reactance. Auxiliary winding high resistance and low reactance. The centrifugal switch is used when the motor will reach to 70 to 80% of full load speed. At that time, the centrifugal switch get automatically open. When this switch is automatically open, then motor will operated on only main winding. Next, same slide. The induction motors are classified as the names. According to this, there are four types. Split phase induction motor. This diagram shows the split phase induction motors. In this winding, a single phase supply is connected to main winding and auxiliary winding. Main winding and auxiliary winding are placed on stator and middle portion is called as a rotor. A centrifugal switch is used when the motor will reach to 70 to 80% of full load speed, then the centrifugal switch gets automatically open. Now, working of single phase induction motors, split phase. At initially, IS is lagged by the supply voltage because low resistance and high reactance. IM is called as the main flux or main winding current. The main winding current is lagged by the supply voltage is very large angle due to the main winding is highly reactance winding or highly inductive winding. At initially, the starting torque proportional to sin Q and disconnect the switch after motor will reaches to 70 to 75% of the rated speed. This phasor diagram shows the supply of V is nothing but the supply voltage, IM is nothing but the main winding current, I is called as the auxiliary winding current. The resultant of IM and IM is nothing but our main current. Okay. Now, the starting torque at initially to 1.5 to 2 times of the full load torque. The starting current of this motor is 6 to 8 times the full load current. Operating power factor is 0.55 to 0.65. The efficiency of this motor is 60 to 65%. Power rating is 1 by 20 to 1 to kilowatt. The speed range of is 2875 rpm to 700 rpm. These are the characteristics of split phase induction motors. This operated as a operating power factor, starting current, starting torque, efficiency, power factor and speed range. The efficiency of single phase induction motor is 60 to 65% because the motor is a rotating part, and when the motor is rotated then the mechanical losses is also present. There are some applications of split phase induction motors. First one, it has low starting current and moderate starting torque. It is used for easily started load, and typically applications include fans, hacksaw, washing machines, grinders, blowers, centrifugal pumps, oil burners, domestic refrigerators, etc. These are the applications of split phase induction motors. Now second type is capacitor start induction run motors. The construction of this motor as shown in your next figure. In these motors, the electrolytic capacitors are used. The auxiliary winding is connected in series with the capacitor, draws a leading current, while the main winding continuously draws a lagging current. Due to the in series with the auxiliary winding, a capacitor is connected. Due to this, the current is leading. Due to these fluxes produced by the rotating field, magnetic field, which results in the rotations of the motor. The construction of capacitor start motor as shown in next figure. The current through the main windings will be lag behind the source voltage because the main winding is inductive, but the current is flowing through the auxiliary winding is lead the supply voltage by some angle due to the presence of capacitor. Hence, the angle between flux produced by the I1 and I2 will be large. Due to this the large angle, the starting torque produced by the capacitor start motors produces a large starting torque as compared to that produced by the split phase induction motor. There are some characteristics of these motors. The starting torque is 3.5 to 4 times the full load torque. Alpha is varies from 30 to 80. The starting torque can be improved because due to the presence of capacitor. The power factor is varies from 0.65 to 0.75. Efficiency is 65 to 70%, and power rating is 1 to 10 to 3 to 4 kilowatt. Next, there are some applications of capacitor start induction run motors. These motors have high starting torque and therefore it is used for hard start load such as pumps, compressor, refrigerators, units, conveyors, certain machines tools. Okay. Due to the use of the capacitor, the starting torque of these motors is very large. Okay. Now next motor, third part, capacitor start, capacitor run motors. Now in capacitor start, capacitor run motors, there is no centrifugal switch is connected. Okay. At the starting condition, at running condition, capacitor is also connected, as well as starting condition capacitor is also connected. The capacitor start, capacitor run motors as shown in figure. There are no centrifugal switch, hence the capacitors will not go out of circuit at all. The auxiliary winding is connected in series with the capacitor draws a leading current, while the main winding continuously draw the lagging current. Due to the flux produced by the rotating magnetic field, which results in the rotations of motor, the constructions of capacitor start, capacitor run, the current I1 through the main winding, that means L1, while lag behind the source voltage as the main winding is inductive, but the current I2 through the auxiliary windings lead the supply voltage by some angle due to the presence of capacitor. The run coil is nothing but a starting main winding or main coil, and auxiliary winding is called as starting winding. Hence, the current angle between I1 and I2 is very large. Due to the large angle, the starting torque produced by the capacitor start motor produce a large starting torque as compared to that produced by the split phase induction motor. Next, the characteristics of capacitor start capacitor run motor. Starting torque is 3 to 3.5 times the full load torque. Efficiency is 60% approx. Power factor is 0.9 approx, that means 90% efficiency. Power rating is 1.8 to 1 upon 8 to 3 upon 4 HP. Full load torque is up to 260% of rated, 26% of rated. There are applications of capacitor start induction run motors. It combines the advantages of capacitor start and permanently capacitor is used for the hard to start load as such as the compressor, refrigerator, pumps, conveyor, etc. These motors are often employed requiring a quiet operating motors such as hospital, studios and so many commercial applications. Next one, fourth one is shaded pole induction motors. The theory of operation is the small motors required only small starting torque, may be self-starting by using low resistance copper bands called as the shading bands. The EMF induced in the shading band causes a current to flow in the bands. These currents oppose the change of fluxes to which it is due to, thus there is a large time lag between flux in the shaded and unshaded portions of the pole. The flux in the shaded portions of the pole lag the flux in the other portions. The result is like the rotating field moving in the direction of unshaded to shaded portions of the pole at starting is produced. This diagram shows the shaded pole inductions motors. The constructions of shaded pole induction motor. It is usually squirrel cage rotors are used. Every stator pole is divided into two parts by keeping a small notch in a pole face, and smaller portion is covered with a thick short copper wire called as a shading band. Shaded poles between main poles. When the stator winding carries the current, it produces a flux phi m. These fluxes with the shading band and this band act as a short secondary. Stator winding is primary circulating current induced in the band produced by the flux phi s. The operations of shaded pole induction motor. This operation is divided into three parts: T1, T2 and T3. At the instant of T1, current is increasing. The induced EMF tries to oppose it. The flux phi s opposes it and resultant flux in unshaded region. At the instant of T2, the current is almost constant. Induced EMF and flux phi s are negligible. The resultant flux is almost in the center of the pole, thus has shifted its positions. At the instant of T3, current is decreasing. The induced current and flux phi s tries to oppose these decreases. Hence, there is a crowding of fluxes in shaded part, and the resultant lies the shaded part, and the motor rotor starts rotating. Next, the characteristics of shaded pole induction motors. The low starting torque, that means 0.4 to 0.8 times the full load torque. Efficiency is 35% approximately. Power factor is 0.45 approximately. Full load torque is 50% of the full load torque, and power rating is 1 by 300 to 120 1 by 20 HP. That means 2.5 to 40 watt. There are some applications of shaded pole induction motors. Because of the poor starting torque, low power factor and poor efficiency, such motors are only suitable for low power applications such as toys, portable fans, electric clocks, hair dryers, slide projectors, humidifiers, small business machines such as photocopying machines, vending machines, advertisement and displacement. Thank you for listening.